Great. So I welcome you all once again to another concept. So we are going to look at the tables for number bases. We are done with the multiplication, addition, division, and subtraction, and we've done basic operations on number bases. In this lesson, we are looking at how we can use the multiplication and the addition as operation for what given base. Okay, so for this one, when we are talking about the tables for number base, normally we use both the addition the addition where we use this symbol. So this is addition, so we use this symbol. Okay, we use this symbol for addition, and we also use what the multiplication, and we also use this symbol. Good. So these are the two operations that we are going to use for tables of number bases. Okay, good. Now in this chapter, when we ask you to construct a table for either addition or multiplication given a base, let's say you are given a base, whatever, we don't know the base. That's let me use, let's say you are given base b. So the base you are given is b. When you are not given a set of numbers, there are times that in a question you may be given a set of numbers. Okay, so when you are given a set of numbers, you don't worry yourself, you use whatever is given in the question. But if you are not given a set of numbers, you base on your table on the specific base given. So let's say you are given base b, then you start writing numbers from 0 to b minus what? 1. Yes, so these are the numbers that you are going to generate, numbers from 0 to b minus 1, where b is the specific what base given. Okay, so it means that the last digit should be b minus 1. That means if you subtract 1 from the base given, that should be your last number, and you are going to write all those numbers for the first column and the first row. So for instance, let's say you are given base 5. Let's say base 5. Now this will be your set of numbers. So you are going to write set of where you start from 0, 1, 2, 3, and then 4, because if you subtract 1 from 4, as we said, b minus 1, then you are going to get what? 4. So that is where you end here. If you are given base 6, what are you going to write? You write 0, 1, 2, 3, 4, 5. Have you gotten that? So whatever base you are given, let's say you are given base 2. If you have base 2, what are you going to write? You are going to write 0 and 1. If you have base 3, you are going to get what? 0, 1, and 2. So whenever you are given a base in this form, you start by writing what from 0 to the base minus 1. Okay, and we are saying that when you are given this one, you need to arrange them in a table form, and you know in a table form we deal with what? Rows and columns. So if we are given, let's say, base 5, how many numbers do we have here? 1, 2, 3, 4, 5. And if you are to construct addition or multiplication, it means that you are going to, let's say, if you are to construct addition table for a given base, you write the addition sign here, then the numbers, the set of numbers you've generated for base 5, you start writing them on the first row. So 0, 1, 2, 3, and then 4. That should represent what? The first row. And on the first column here, you write 0, the same numbers, 2, 3, 4. So you just use, so this will be in a table form. So this is just a normal sketch that I'm just doing to explain to you. Okay, good. You draw a table like this. So whatever is given to you, you are going to add them. Okay, so if you are given addition in base 5, what you do, you add it. Okay, when you add it, so we add the first column. So 0 plus 0, you write your 0, plus this, you write a 1. 0 plus 2, you write what? 2, plus 3, 3, and then 4. Then you come to the next one. So you fill in all there. So let's try and fill this one. 1 plus 0, you are getting what? 1. 1 plus 1, you are getting 2. And here will be 3. Here will be 4. And here will be what? 5. For addition, when you start adding up, you realize that it will be following a pattern. So if here is 0, then here will automatically be what? 2. If here is 2, after 2, where do you move? 3. Then here will also be what? 4. But let's look at something here. So in this table, because we are dealing with what? Base 5. Remember that when you are if you are dealing with base 5, when you get to a number which is the same as the base or greater than the base, then you still apply what? The remainder principle. Remember that when we're doing the multiplication, addition, subtraction, and all that, we did what we call remainder principle. So after getting the number, then you divide that 5 by the base. Okay, and what will you get? So 5 divides 5 how many times? You get 1. Remainder what? 0. So this and that, you write all of them here. So instead of 5, here should be supposed to be what? 1 0. Have you gotten that? So here is supposed to be 1 0. Okay, so when you get here will also be 5. And when we got 5, what did we write? We wrote what? 1 0 here. Now let's add this to this. We are getting what? 6. Then the 6 you divide by the base. So the same way we dealt with the multiplication, the addition, by using remainder principle, is the same thing we are doing here. Okay, good. So 6 divided by 1 and 5, we are getting what? 1. Remainder what? 1. So it means I'm going to write this and that here. Have you gotten that? Great. Whereas the case, then here will be what? Because we are saying 0, 1, 2, then here will be 3. Here will be what? 4. Now after 4, what do you get? You get what? 10. After 10, what do you get? You get what? 11. So if I'm getting 11 here, then my next box will be what? 12. Okay, and why are we saying 12? Let's test and see if it is 12. So it means that 3 plus 4 gives me what? 7. Now 7 divided by the base is giving us what? 5. So it means that 5 divides 7 how many times? 1. Remember what? 2. So we write 1 and 2 here. That's why we have this. Now if here is 3, then here is what? 4. Here will be what? After 4, what do you get? You get what? 1 0. After 1 0, what do you get? You get 11. You get what? 12. Then here will be what? 13. So you see how we fill the table. So still the remainder principle what applies here. So this one is very what? Basic. Okay, now let's take a full question on this, and then we see how we can go about it. Know that we are talking about addition and multiplication. Okay, so for addition and multiplication, it follows the same principle. The only difference is that if it is addition, you add and then you apply the base. If it is multiplication, you multiply, you apply the base. Okay, so the same thing works for what we've done previously in addition and multiplication of number bases. The same thing works here. The only difference is that this time we are adding to fill what? In the table, the spaces in the table. Okay, all right, great. So let's quickly take one example on this, a full example, and then we see how we can go about it. All right, so let's look at this full example and see how we can solve this one. So this one, we are asked to draw an addition table for base 6, and after the table we are to use our table to look out for all these. So let's quickly look at how we can draw the table. So as I said, when you are asked to draw addition or multiplication table, whenever the set is not given. So remember, I said there are times that the set may be given to you, so you don't need to worry yourself to write another set. Whatever is given in the question, that's what you use. But in this case, there is no set given, but we are given in base 8, so you have to write the set yourself. So in writing the set for base 8, you know that the set is going to be what set is going to be. So for base 6, you know that we start from 0, 1, 2, 3, 4, and what? 5. So this is what we are going to use to construct or draw our table. Okay, so that is the case, and we are also asked to draw our addition table. So we start with our addition sign. So we have what? On the row side we have 0, 1, 2, 3, 4, and 5, and the column side we have 0, 1, 2, 3. Good. So we have this table 3, 4, and a 5. Okay, so we are going to fill in all the boxes here. Okay, all right. In base 6, so it's just addition. So we know that here is 0, 0, 1, 2, 3, 4, 5. Okay, so let's just fill in the table by adding. So we know that this plus this will give me 1. Here will be 2. Here will be 3. So it follows a pattern like that. And here will be what? 4. This is 5. And here will be 6. But remember, it is in base 6. So if it is 6, then 6 divided by the base itself, which is 6, which will give us what? 1 remainder 0. So it means that we are going to write 1 0 here. Then let's come here. If here is 1, here is 2, here is 3, here is 4. This is what? 5. Now after 5, what do you go? You go to 10. If here is 10 or 1 0, then here will be what? 1 1. Okay, because you get what? 7, and 6 divides 7 how many times? 1. Remember what? 1. And here will be 3, 4, 5, and then we have what? 6, which is 1 0. Here is 7, which is 11. Here is 8, which is what? 12. Then we have here to be what? 4. Here to be 5. Here is 6, and then 10. 7, which is 11. 8, which is 12. And then 9, which is what? 13. Here's 5. This is what? Is 1 0. 1 1, 1 2, 1 3, and then 1 4. Good. So you fill in all this. After that, then you look at the other examples, and we are for the B, we are asked to use the table to find I. So for I, we are to find what? So this is what we are looking at. Good. So whenever you have something like this, you always have to deal with what is in the bracket first. Okay, so it means that 3 plus what? 2, and we are asked to use our table. So we go to the table, look at where 3 is. We locate a 3 here. Okay, and then we locate where 2 is. So where is my 2? Good. So you trace it from this 3, you trace it to what? 2. Okay, then you realize that you have this here. Okay, so it means that 3 plus 2 gives me what? 5. Then you add your plus again, then 4. So you are going to look at for this one. Okay, so 5 plus 4. So I'll look for 5. 5 is here. Then I'll look for where 4 is. So 4 is also here. So I will trace it here and here. So you realize that the answer is what? 13 or 1 3. Okay, so that is how it is done. Now let's look at the second one, which is 2 plus 4 plus 1 plus 3. So for this one we do what is in the bracket first. So 2 plus 4. Now on my table we see that we have 2 here and what is 4. So 2 is here and 4 is here. So it means that this is 10. Then plus, so 1 and 3. 1 is here. What is my 3? 3 is what? So it's 4. Okay, good. Now once you have 10, 1 0 here, and then you have 4 here, you are going to apply this one. And the question says we should use our table. So you locate where 10 is here. So you realize that in the table, for the columns at the set, you don't have 10 there. Okay, the set given, because it is the set that you use. So whenever you are using the table, you need to consider the set that you use to what? Draw or fill in the first column and the first what? Row. So you realize that the first column we don't have 10 here, the first row we don't have 10 here, so 10 is not in the set. Okay, so once you realize that you've gotten a value which is not in the set, even though it is here, but that's not what we are talking about. We are talking about whether the value you have here is in the set. Once you realize it is not in the set, then you just write no solution. No solution. That's all. If we were not asked in a question, if we were not asked to use a table, you are just asked to find the value of this. This time what we would have done is, without using the table, would have added this to this. This is 10 plus 4, which will be what? 14. Then after the 14, we apply the base. So if not, because we are restricted to use the table, okay, if we had been asked to just find the value without even using the table, would have added this to this, and we get what? 14. Then after getting the 40, then we apply the base, which is base 8. So it means that 6 will divide the 14 how many times? 2. Remember what? 2. So in that case, our answer would have been 22 or 22. But in this case, we are using the table, and the set given, you have to be what? Be in line with what? Or you should be in the domain. The answer you are going to find, or whatever value you are going to use, should be in the domain of the set. Have you gotten that? Great. So let's try the C. So this is B. Okay, and then the C. So for the CI, we have to use the table to find or to solve 4 plus M is equal to 13. So it means that we are looking for the value of M. So in this case, if you want to use the table, then it means that when you add 4 to a certain number in the set, you must get what? 13. Okay, so let me locate where my 4 is. Okay, let me locate where my 4 is. This is where my 4 is. Then you trace it to a portion where you can get what? The 13. So this is the 13 here. Then you trace it upwards and look at the number that was added to 4 to give what? The 13. So you realize that this is what? 5. It means that it was 4 plus 5 that gave what? The 13. So you conclude that therefore our M is equal to what? 5. Have you gotten it? So it's very simple. All right, great. Now let's look at the II, where we are also asked to solve M plus 1 plus M is equal to 11. So here we come again. So here too, it means that if I pick a number from the set, okay, If I put it here and add to 1 and add to the same number, I must get 11. Okay, I must get 11. So this one, you need to test all of them and see. Okay, you need to test all of them and see. So if I'm picking 0, then it means I'll put 0 here, I'll put 0 here, and check if I'll get 11. So if it is 0 here, so it means that my 0 plus 1 plus 0 should give me 11. So we are testing all of them. Okay, so 0 plus 1, we know that from the table, 0 plus 1 gives us what? 1. Okay, 1 plus 0 again. And that shouldn't be equal to what? 11, because 1 plus 0 again is what? 1. So this is not true. Then we move on to, we test with what? 1. Okay, test with 1. If we are testing with 1, then I will try 1 plus 1 plus 1 again. Is it going to be 11? Is it going to be 11? Good. So 1 plus 1, we know that from the table, 1 plus 1 gives me what? 2 plus 1. Is it going to give me 11? No, because 2 plus 3 on the table is also giving what? 3. Okay, which is not equal to 11. So we test again. We try what? 2 plus 2 and 1. Then we have plus 2 again. Is going to give me 11. So 2 plus 3 on the table, 2 plus 1 gives us what? 3 plus 2. So it means that 3 plus 2 gives us what? 5, which is not equal to 11 as well. So let's try 3 again. And 3 plus 1. Is it going to give us that answer? Okay. So 3 plus 1 gives us what? So 3 plus 1 gives us what? 4. Then plus 3 again. So 4. Okay. 4 plus 3 is going to give us what? 11. It's going to give us 11. So it means that this one satisfies what? The condition. Okay. So what value did we replace by what? M to give us what? That 11? It is 3. So here we can say that M is equal to 3. Okay, good. Now let's see if we check 4. So if 4 plus 1, let's see if 4 and 5 will also work. 4 plus 1 is what? 5. And 5 plus what? The 4. So 5 plus 4 gives us 13. So it doesn't work. 5 plus 1 gives us 10. And 10 is not even in the set. So it means that this is the only answer we have. M is equal to 3. So questions like this, that is how you can go about it. All right. Okay. There. So this is an example on addition. Okay. So in our next video, we are going to solve one more example on the multiplication. Okay. There are times that the question, you may also be given a question to construct both a table for both addition and multiplication. So take note of that. We can combine the two. Okay, so in our next video, what I'm going to do is that I will combine the two. I will add the multiplication to the addition, and then we see how we can go about it. All right. So I'm your facilitator, Evans Okan. The name of the channel is Mazris TV. Don't forget to subscribe, like, and share. See you next time. Bye bye.